in here because this exists here and it exists here, right? The CCCCAA, it's in the output because it exists here as well as existing here. Now, something you might notice is that the A's and the C's are shared, right? So you're not stuck with your substring. Your substring is every possible substring, right? So that's something to know. So when we're solving this, we know we're going to need an output array. So add that to the playlist, right? We'll say let output, and we will have our output array, right? We all should have got this far. We also said that we need to be able to loop through this to get every possible substring. Okay, so if we know that, we're going to write our loop. So we can say for let I, where's a good spot for I to start? 0, right? Because we want from the very first letter in this string. While I is less than. And when should we end? Should we go all the way to the end? Do I need the next 10 letters from this G? No, right? So I don't need to go all the way to the end. So I'll just say s.length, and we'll go minus 9. I don't want to go minus 10 because I don't want to drop 1. Okay? And how should I be incremented? By 1, right? Because we want to continue to look at each one. So let's go ahead and say I plus equals 1. Okay. So now we said we want to be able to look at every sequence, right? So let's go ahead and create a variable called like sec for sequence. Let's sequence. And how can I take a little section? How can I do that? What's a method we know about? Slice, right? Like you're slicing something apart. So we'll say s.slice. And we want to start from where?
0.
What about in the next iteration? We want to start from I, right? I is the thing that's going to be our traversal. So we'll start from I. I is inclusive. And we want to go to where? I plus 10, right? Exclusive. So that way our thing will be a length of 10. Okay, so now we've got this nice little sequence. And so we said we want to actually save these sequences somewhere, right? So we got to create an object. Should I create the object in the for loop or before the for loop?
Before the for loop.
Why?
Because you want it.
Go ahead, Henry. You're the loudest. Go for it. You're doing good. Don't worry. Go for it. No, you're on the right path. Go for it.
Because the thing with the loop is that once it gets to that 10, it'll stop running. So you want to.
Okay. Someone else. Marvin.
Because we're going to be updating that account, we're trying to actually see how many times that thing occurs.
Yeah.
Maybe we'll just keep restarting, keep it outside the loop. We'll see like an actual update how many times we see the set.
Yeah. Somewhat. What's the sentence I'm looking for? Isaiah?
It will reset at every index, every new index.
With every iteration, right? If we put it inside of the for loop, with every iteration, that variable will be reset. So that's not going to help us remember what we've seen, because it would keep resetting. So because of that, let's go ahead and keep track of a let scene, and we'll make that an object. Okay, so now we have to add this sequence to our scene and associate it with the amount of times we've seen it, right? So how can I check if we've seen the sequence? Someone raised their hand, maybe who hasn't spoken yet. How could I check if this key exists? Will? What?
You can account for it, but if you see it again, just keep adding.
Yep. tell me a little bit more about just how I can check if that's in there.
If the sequence key matches the value.
Matches what value? We just want to see if it exists.
Oh, so if object,
See?
I mean, if C at, you put the square.
Yeah, bracket.
C.
Yeah, if seen at sequence, right? This means we've seen it. If we've seen it, what do we want to do? Add a 1 to it. Nice, Dan. Seen at sequence plus plus. Else, what do I want to do? Karen? Yeah, right? If it's the first time we've seen it, we want to set it equal to 1. Okay. So this looks good. Yeah, she. Sequence is just taking a slice of the string. So it's giving me that substring of 10. I'm writing it out this way so that it's more readable, so I can keep reusing it. I don't want to keep slicing over and over again. So if we've seen it before, what else does that mean we can do? Marvin?
Yeah.
Okay, so let's say we've seen it. So we've seen this. So I'm also going to push this into output. You're saying. All right, let's try that, and we'll push our sequence. Is there any foreseeable problems with this, Valor?
It is about, it only wants 1 if you see it more than once. So if you do it that way, if it already exists, you can push it 3, 4 times. As many times as you see it again, you'll keep adding it.
Okay, great. So so what Valor says is we could end up with too many occurrences pushed into the output. So let's say our string was A, 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 and let's pretend again I'm looking for only 3s. Okay, it's the same problem conceptually. Right, we have an A here. We wouldn't push it. We would have our A sequence here. We would push it. And then we would see another one here. We would end up pushing it again. But we don't want to keep pushing it. So what's a way around this? Yeah.
You could either push them to the array at the end, or you could use includes to make sure that it does not include that.
Okay, so Valor comes up with a couple of options. One is we don't do it here, and at the very end we iterate through the object. That's possible. One of the things I don't like about that is that object could be very big, and I don't want to spend all my time going through this whole object again. The other option he offers is we could check if the array already includes it. Okay, nothing wrong with that, but again, we're going to be iterating through this whole array again, and we don't know how big that array is going to get. Can we think of another way?
Can we check to see if the value is more than 2?
Okay, so Danny says, can we check to see if the value is more than 2 right now? Yeah, right? Or we could even check if it just is 2. Because if it's just 2, then it's time to push. So let's go ahead and just throw another if in here. And we say, hey, if seen at sequence is equal to 2, this is like then let's go ahead and push our sequence into our output. All right, and let's at the very end return our output. Let's see how it goes. So first we'll run the code, see if there's anything completely breaking. Okay, that looks like the right answer. It was accepted. So let's go ahead and submit. And it seems to work. It's not the fastest solution in the world. There is faster ones. But it works, right? And that's all that really matters at the moment. Is there ways for us to refactor this? Is there anything that looks kind of ugly? So we can't use for each because for each is an array method. I think we could like turn this into one line, this whole if else thing, by doing something like scene at sequence. So this is either going to give us undefined or a number, right? And if I could say is equal to scene at sequence plus 1. So that would either be the number plus 1 or undefined plus 1. Undefined plus 1 gives us what? It gives us NaN, not a number, which has a truthy or falsy value. Falsy. So I can also use the OR operator and say OR is equal to 1. And if I do that, then I can get rid of this line and this line. And I should still be able to submit. So if I actually remove the comments, it would look a little bit cleaner. And it's also a little bit faster. Right, this is the advantage of the OR operator. It returns the last value it read. So it's either going to give us the number plus the 1, and NaN, and move over to here, and give us back the 1. So let's go ahead and delete those. So it's cleaner. I think that's probably as clean as we need it. Any questions on that? All right, so it's okay if this problem is tough. It's kind of a sliding window problem where we're going to keep moving this window of 10 along the way. There's a lot of problems out there like that, right? We're using a counter object, which is like my favorite thing that I talk about a lot, like counting occurrences of things. They show up a lot. Right, there's ways to do it without that. You could use a data structure called sets and stuff, but object is pretty intuitive. No questions. Questions? Anything? Thoughts? Concerns? Okay, great. All right.